In this video, we're going to continue factoring polynomials. We're going to talk about two other types or ways that we factor polynomials. We're going to talk about special forms and repeated factoring. So, special forms, there are quite a few of them. See page 63 in your textbook or your class notes for these listings. Hang on to them because they're really useful for us in this class and also in pre-calculus. The notable ones I want to talk about in this video are difference of squares. So here I have a quantity a squared minus a quantity b squared equals a minus b times quantity a plus b. We also have perfect squares. A squared plus 2 times ab plus b squared. We can factor that as the quantity a plus b quantity squared. Similarly, we have a squared minus 2ab plus b squared equals quantity a minus b squared. So if you see polynomials, or you can rewrite a polynomial so it looks like one of these three forms, this one, or this one, and you get good at it, you can automatically jump to their factorizations. Really good habit to get into. I find these are very useful. So, let's do a couple of difference of squares problems. Examples. So we want to factor the following polynomials completely. We have x squared minus 144. Now, what I'm going to try to do is use the difference of squares. So I want to rewrite this as a squared minus b squared. Now we know 144, I can write that as 12 squared. And I want to do that because that's going to help me recognize that this is a difference of squares. Having done that, I now know I can write this as x minus 12 times x plus 12. You could go ahead and factor this using guess and check method or any other way, but you should end up with the same factorization. Okay, a little more complicated. 81x to the fourth minus 16y to the 8th. This really doesn't look like a difference of squares problem yet. But let's notice that 81, I can write that as 9 squared. Same thing with 16, I can write that as 4 squared. So I'm going to rewrite this as 9 squared times x to the fourth minus 4 squared times y to the 8th. So we've taken care of these constants, and they're looking similar to these squareds that we're looking for. We're not quite there yet, though, because we need to recognize x to the fourth and y to the 8th that can be rewritten in another way. The way I want to do that is, so here's my side work. X to the fourth, we know from our exponent rules, I can write this as x squared squared. So I'm going to write that over here. So I have 9 squared times x squared squared minus, and along the same lines, y to the 8th, I can actually write that as y to the fourth squared, so 4 squared, y to the fourth squared. And again, using another property of exponents that we learned about earlier in this chapter, since I have a 2 on each of these two terms, I can go backwards. We learned that we could distribute inside the parentheses exponents onto each term, but I can also go the other way and write this as 9x squared squared minus 4y to the fourth all squared. Now hopefully this looks like it's in the form of difference of squares, and it is. So I'm going to come over here and write this as 9x squared minus 4y to the fourth times 9x squared plus 4y to the fourth. We can even do a little better in this problem, and this is where we start to talk about repeated factoring, which is starting on this slide, and we'll continue through the rest. Using the same kind of logic that we did with the original problem, I can rewrite this first factor as 3x quantity squared minus 2y squared quantity squared times 9x squared plus 4y to the fourth. Now this term or this factor is irreducible or prime. But now we can continue. This one we've written as a difference of squares, so let's use what we know. I can write that as 3x minus 2y squared times 3x plus 2y squared times, running out of room here, what's left? 9x squared plus 4y to the fourth. And if you so desired, you could go back and multiply all these out. You would start by foiling these two and then distributing that into this, and you should get back to the original problem. So let's do some repeated factoring, and let's talk about our steps about how to factor a polynomial that we're given. So remember, step one, GCF. And pretty clear in this one, we can see that our GCF is going to be 2x. So first, factor out a 2x, leaving me with x squared plus 4x plus 4. Handily enough, this is one of our special forms, and this is a perfect square, so this will be x plus 2 squared. Now, if you wanted to factor this one, this term, x squared plus 4x plus 4 on its own, I would suggest guess and check. You would do x, x. Then remember, we need two numbers multiplied together that'll give us 4. We only have two options. We have 2 times 2 or 4 times 1. 4 times 1 isn't going to work because when we add our outside and inside, we end up with 5. So we're going to need 2, 2, and both positive, yielding the same answer that we got using the special forms. A little more complicated here. Again, factor the following polynomial completely. So first thing you want to try is GCF. Now we start looking at x's. Well, these two don't have x's. Move on to y's. Well, these two don't have y's. So there's no x's, there's no y's, and it turns out that the greatest common factor is 1 for these terms. Notice next that we have 4 terms. So that kind of clues me off that I'm going to want to factor by grouping. So I'm going to group the first two together. Now the only common factor there is going to be y, and I'm left with x squared minus 16 plus, greatest common factor for these two is a 2, leaving me with 16 minus x squared. Now these two terms aren't the same yet, but they only differ by a negative. So what I need to do is factor out a negative from this term, leaving me with x squared minus 16. Now I can use the GCF, x squared minus 16 times y minus 2. And last thing we need to do is ask ourselves, well, this polynomial is of degree 2. Can I factor it? Indeed we can, and we would recognize as we get more practice with these that this one is also a difference of squares. So this is going to factor as x minus 4, x plus 4 times y minus 2. So how many methods did we use to factor this polynomial? First we started with, well, we tried GCF, but that didn't work, so we didn't use it. We then went into grouping, so we factored by grouping. In the process of factoring by grouping, we factor using GCFs. And last thing we did was one of our special forms and difference of squares. Another example, so y to the 5th minus 81. Pretty clearly we see that we can factor a GCF of y out. Always start with GCFs, okay? Now we may or may not notice that this is actually a difference of squares. If we're not sure, see if you can write it so it's something squared minus something squared. Now in order to make that work, I would need a y squared here and a 9 there. So I'm going to factor as a difference of squares y squared minus 9 times y squared plus 9. And each of these two factors is of degree 2. So I want to ask myself, can I factor these further? Well, y squared minus 9, again, we're seeing a pattern here. We just want to keep asking ourselves, can I factor? Can I factor? Can I factor further? Y squared minus 9, we sure can. Y minus 3 and y plus 3. Y squared plus 9 is prime, or irreducible, and we are not going to be able to factor that one further.